Hi everyone, this is Mrs. G.A. and today we're going to learn about Pascal's Triangle. So first we're going to talk about what Pascal's Triangle is. So Pascal's Triangle, it is literally a triangle of numbers, and for each new row, every entry of your new row is going to be the sum of the two entries that are diagonally above it. And that's going to be every row except for row 0. So we always start with this 1 at the top, and we call that row 0. So if you look at row 1, this first entry, there's only one entry diagonal to it, it's 1. So both of these, you look above, there's only one above, so it's just that single term. For row 2, you start on the outside, the only term above this is a 1. But if you're looking at this entry, this one does have two diagonal entries above it. 1 plus 1 is 2, 1 plus 0 is 1. And then on the row 3, right, 0 plus 1 is 1, 2 plus 1 is 3, 2 plus 1 is 3, 1 plus 0 is 1. And you can see that this pattern continues in each successive row. So again, for each entry, you're going to look at the two entries diagonally above it. Sometimes there isn't an entry there when you're on the side, so just count it as a 0. And again, please note that this very top number, this 1, we call this row 0. We don't count this as row 1. So now we're going to talk about one application of Pascal's Triangle. So we can actually use Pascal's Triangle to help us expand binomials. So what I mean by that is, well, let's just take a basic binomial like x plus y, and let's say I wanted to expand it to the 6th power. If you were actually going to sit there and multiply x plus y by itself 6 times, that would be pretty time consuming. There's going to be lots of different steps, and the chance of an error is pretty high. So we have this method of using Pascal's Triangle that kind of helps us, expand quicker and a little bit more accurately. So here's how we are going to be using Pascal's Triangle to do this. First, you find the row in Pascal's Triangle that matches the power you're raising the binomial to, which we'll call n. So if I was using this, I would use the numbers in row 6 of Pascal's Triangle. These numbers are going to become part of the coefficient of each term, so I actually list them out, and you leave some space in between. And then moving from right to left for each term, the exponent for the first term in your binomial is going to decrease from n to 0. So your first term should have x to the power of 6, the highest power. The next term should have x to the power of 5, then x to the power of 4, and that continues on until you get x to the power of 0, which is 1, okay? And then moving from right to left, the exponent of the second term of your binomial is going to increase from 0 to n. So you kind of do the exact opposite. So your first term would have y to the power of 0, which disappears, it becomes 1. And then you'd have y squared, y cubed, y to the 4th, all the way up until you reach y to the 6th, or whatever this n value is. So your first term is going to decrease in power, and your second term is going to increase in power. And then all you need to do is multiply everything together for each term, and then that will give you your expanded binomial. Okay, so let's give one of these a try together. So first, you'll notice that we are raising this binomial a plus b to the power of 7. So I'm going to find the numbers in row 7 of Pascal's Triangle, and I'm going to list them out, and I'm going to give myself a lot of space in between. So row 7, the numbers are 1, 7, 21, 35, 35, maybe a little more space, 35, and then 21, 7, and the last one will be 1. One thing you'll notice is that there's always going to be one more term than the power. So here you can see that we actually have 8 terms when we're raising it to the power of 7. So here's that first step. So now we're going to be taking our first term in our binomial, which is a, and we're going to decrease the exponent as we go from right to left. So we can start with a to the power of 7, and then a to the power of 6, and then a to the power of 5, a to the 4th, a cubed, a squared, a to the 1st, and then a to the power of 0, which will turn into a 1. And then we're going to do the same but in increasing order for b. So for b, we would start with b to the power of 0, and then we have b to the power of 1, and then b squared, and then b cubed, b to the 4th, b to the 5th, b to the 6th, and b to the 7th. So now that we have everything listed, we would just go through and actually multiply every part of each term together. So the first term is simply just going to be a to the power of 7 plus 7a to the 6th b plus 21a to the 5th b squared plus 35a to the 4th b cubed plus 35a cubed b to the 4th plus 21a squared b to the 5th plus 7ab to the 6th, and then plus 1 times b to the 7th. And then this is our expanded binomial. So even though this process does take a little bit of time, I can guarantee you that this process that we went through together, even though it's our first time doing it, is going to be faster than actually sitting there and multiplying a plus b by itself 7 times. So this process can actually be a really big time saver. Okay, we're going to try one more together. So here we have the binomial 2 minus 3x, and we're going to raise that to the power of 5. So remember, the first thing we should do is we should list out the coefficients or the numbers from row 5 of Pascal's triangle. So it's 1, 5, 10, 10, 5, and 1. So notice again, we have 6 terms when we're raising it to the power of 5. Now we're going to go through and take our first term, which is 2, and we're going to decrease the exponents from 5 to 0 for each successive term. So here we would have 2 to the power of 5. Let me go in and add little plus signs in front of these. Okay, here we'd have 2 to the power of 4, 2 cubed, 2 squared, 2 to the 1st power, and 2 to the power of 0. And now for our second term, which, be careful, is negative, we're going to place negative 3x, and we're going to decrease the power, or increase the power, going from 0 to 5. So make sure you include that negative in every single term. So negative 3x to the power of 0, negative 3x to the 1st, negative 3x squared, negative 3x cubed, negative 3x to the 4th, and last negative 3x to the 5th. Now here we actually do need to do a little bit more multiplying out than the last one. So here this term is going to disappear, and we have just 2 to the 5th power, which is 32. Be careful in this next term. Since we do have negative 3x to the power of 1, this term is going to become negative. So then you do 5 times 2 to the 4th times 3, and you should get 240. So we have 240x. Now for this next term, notice that when we square this negative, it is going to become positive. So our next term is positive. So here we have 10 times 2 cubed times 3 squared. So make sure you're multiplying every single part together, giving us 720x squared. The next term is negative because our power is odd for this negative term. So we have 10 times 2 squared times 3 cubed. Don't forget to cube the 3 as well. And that gives us 1080 x cubed. Our next term is positive, and we have 5 times 2 times 3 to the 4th power, which is 810, and then we'll have x to the 4th. And then for our last term, we have 1 times 2 to the power of 0, which is 1, and then that leaves us with negative 3 to the power of 5, so it is going to be negative 243, and then we have x to the 5th. So here it does show how important it is to actually write out every term when you're expanding using Pascal's triangle. Be really careful with the negatives and make sure that you are cubing or squaring the entire term, both the variable and the coefficient. Okay, so at this point, I'm going to ask you to pause the video and give this last one a try, and we'll check your answer in just a few seconds. Okay, so for this one, you can see that I started by listing out the numbers from row 5 of Pascal's triangle. And then for my first term, 3, the exponents decrease from 5 to 0. And for my second term, which be careful is negative x, my exponents increased from 0 to 5. So check your answer here and do be careful that you have those alternating signs for each term. Okay, that is all for today's video. Thank you so much for watching.